So today I have this project that is, it's a sand simulator, but I want to make it data driven because right now, also it's very slow, but I'm not going to worry about that today. If there's too many particles, it drops because it's CPU bound, but whatever. So what I want to do, hold up, what is happening here? Okay, that does not matter. Okay, so I'm going to check out, I don't know, data driven. That's probably fine. And then what I want to do is I want it to look like particles, want there to be a folder called particles, and then inside the folder, you define a particle with some, I don't know, some stuff. So say we want to make a particle like sand. Sand.p is p, extension, is this a thing? Python pickle files, Pascal source file, what about a part for particle? Yeah, I guess those are things. What about PRT? Extensions list, file extensions list, common file extensions. Sure. Oh, there it is. Wikipedia. Oh, that's a lot. I want it just in alphabetical order. Okay, let's look at this one. I mean, I think .p is not gonna be a problem, right? P. Okay, here we go. I think .p is gonna be fine. I don't think I have any .p files, so we'll just define like a .p file, and then the first thing we'll define is the name of the particle, the symbol to reference it inside of the code, which will just be one character, and we'll figure that out. A color would be nice. You know, yeah, let's define a color. I have here, I don't know where I define the actual particle. Somewhere down here. There it is. Okay. Yeah, let's just yoink this and go to particles, and we'll just say that that's the color. I don't know if I want to define the hashtag, but whatever. So name, symbol, color, and then here we need to define the rules. And what I want it to be like is, so a particle has eight neighbors. So I think the rule is I want it to be like, oh, it needs to be this, and then the next state is this, right? So in this case, I'm going to use the asterisk as it doesn't matter what's there, and then the period, I guess doesn't matter. We can specify that it's sand, but I suppose it doesn't matter. And then we'll have the period be an empty, so this doesn't matter, and then it'll go in order. So like say that this is the case and it doesn't matter what the particle is, I just need to get that the bottom one is empty. So then what I can do is I can say, oh, if the bottom one is empty, then what I want it to be is that the next iteration, this is empty and this is a sand particle. And that's the only difference that I want to do. So that's one rule, and then I'll do it like this. Will I do it like this? Maybe I'll do like this to specify. I also want a way to define like random rules. Because for example, next we could define, I don't know, I'm just gonna leave that in for now, and we'll figure it out later. So for example, the problem is, okay, say this one is anything that's not empty. Well, it doesn't matter in this case. In this case, we don't care what this one is, because if it was empty, then we would have already replaced it. So if this is on the side, then we'll just keep that there, and then we'll place this with a sand. Okay. So the problem is we have these identical rules, right? Where this is now an asterisk, and this is a period, and this is the S, and this is an asterisk. Oopsie. Right? But I want these to be done. Do I want them to be random? I don't think I want them to be random. I think I'll just define first left and then right. Okay, so we'll say that this is like a particle file, and that these are the rules that the sand follows. And now what I need to do is now I need to parse this within the data, within the file. So now we need to come here, and we need to come here, and yes, we have the updates, the add particles, and the whatnots. But now I need to have more. Now I need to parse a particle. I have a particle type, right? Yeah, I do. Okay. So we'll get a particle pointer, and we'll parse particle. And then what we'll take is we will take in a file, just a file path. A file path. And then we'll parse that. And then we'll figure out how we do that. But for the time being, just particle P, particle P, size of particle. Okay. And then we'll open the file. So we'll just fopen. Fopen is, yeah, it gives me the file. That's what I wanted. File equals, here we pass in the file path, and I literally think that's just like rewrite and whatever, and then we'll close file. Okay. I'm just gonna do a bunch of this so it's not at the very bottom, but I'll delete that later, that doesn't matter. Okay. Okay, so now, first, we're gonna need to change this for sure. Yeah, because we just have an x coordinate and an so we'll just name, symbol, ID maybe. I don't know. We'll call it ID for now. We will say the color. How are we doing the color? It's 6 bytes. Is it 6 bytes? I think it's 6 bytes. I think each of those is 1 byte. I think it's 6 bytes, which means we can store it. I'm going to store it in 3 different things. Uint 8 R G B. Yeah, I'll spell it out, just so I never forget what it is. Blue. Could I stuff this in a color class? Maybe. Don't care. SDL uses RGB, so that's fine. I don't want that to be in here. Put that there. And then what was the other thing? Oh, the rules. Yeah, the rules. So now I need to define a rule. Okay, well that's fine. That shouldn't be too difficult. And this particle type is just not a thing anymore. Because that's just in the ID. Yeah, the ID is going to be fine, and then we have an X and Y, and then we're going to have a list of rules. And a rule count. And we'll define a rule, type of rule. And the rule is going to be, it's going to have an input and an output. So just 9. Do we care about the middle one? That's my question. Do we care about the middle one? Do we want to specify what the middle one has to be? No. We won't. So what I mean by that is, if we come here, it doesn't matter what we put here. I think we'll ignore it. No, we do need to know for the output, because we need to know what happens to it. Okay. So Here we go. Come all the way up here again. Oh, it's in the dot HS maybe. Okay, so it does need to be 9, 9, input, output, and why is this an 8? Okay. Oh wait, it goes here. Always get because the other thing is there. Okay, so we have an input and an output, and that's all the rule is. It's just we just put that everywhere. Okay. Doesn't seem too difficult. Correct. And then we don't add a particle anymore. We'll just straight up we'll just straight up pass in. Oh boy. I guess we want, instead of a particle, yeah, okay. We particles I think are gonna have the same thing as before. But we're gonna have, instead of having each particle have the same stuff, we're gonna have struct s particle type particle type, and then all of this stuff is just gonna be here and here. Goes, and then we have a particle type. We'll have a pointer to it. And why is this not showing? Why are these showing as indented, but what in the world is going on? Yeah, that was weird. Okay. Yeah, so that should be fine. Sorry, censoring text. Okay, perfect. So when we then parse, okay, 1 second. I'm back. It's a bit brighter. Anyways, where were we? I think we were parsing this. Yes. So let me come here. Let me just grab this, just so I can. Hold on. Let me grab a full rule. And we'll just be able to repeat this, right? Oh yeah, I'm gonna have to figure all that out. Right. Oh, that's right. Okay, so we don't actually want to parse a particle. We want to parse a particle type, I think. Particle type. Just throw this here. Right. And then I don't actually want a file path. I just want a particle string. Because I feel like maybe we want a different way to input these values. And so at least for now, we'll pass in a string. We'll handle the file stuff later. So now we have a string and it has that form. So what we need to do is we need to grab from the string until the first line break. So I don't know. How do I find stuff in C? Do I just name? I'd like to know when it is. Like, oh look at that index. What does this do? Yeah, that doesn't help. Okay, man index. Yeah, there we go. Okay. Oh, it's deprecated. Okay. Index is identical to strchr. Use strchr and strrchr. Okay, so man strchr. Oh, spell it correctly. Okay. Functions return a pointer to the matched character or null if the character is not found. The terminating byte is considered. Okay, who cares? And there is no difference. Oh, maybe R is probably reverse. To the last occurrence, yeah, so it's reversed. Okay, perfect. The null, except that if C is not found, then it returns a pointer to the null byte at the end rather than null. I don't think we're going to need that. But we will use, so this returns a pointer. So this returns a pointer. So it's like a name end. And this equals strchr. And we pass in a particle stir. And we're looking for int c. That's a character. Okay, so we're looking for a line break. So now we have the distance between the end of the name. Now we have the index to this implicit end. So then we need to get the actual name. Will be an str dupe. Str substring. Str. Okay, hold on. Str sub string. Is there not an str substring or something? Man substring, man strings, I guess, at this point. Yeah, that's not what I meant. Man 3 strings. Man strings.h. There we go. That's not it. There's a way to get a substring in. Just don't know. Substring. Let's see. It's a stir. Okay. That's wild. Okay, so what do you do? Here. Stir. Haystack needle. Oh, it finds a string. The first occurrence of the substring, terminating no bytes. Not compared. That's not what I want. That's not what I want. You can extract a substring using function. No. Get a substring. I don't particularly like geeks for geeks, but yeah, I guess strn cpy. I guess I should have just done that, yeah. Okay. So strn cpy. So we're gonna copy. Okay, and then I don't actually remember. It's first is the destination. Okay. Here we go. So first is the destination. The destination is gonna be the name. Wait, what? What does it return? It returns the destination. Okay, whatever. Who cares? First is the destination, and then it's going to be the particle string. And then for how long? It's probably going to be, well, name end minus, name end minus particle string. I don't know if that will 100% work, but yeah. Okay, so now ideally we have the name. Then we need to name end, and we just need to add one to it because I want it to go to the next line, to the actual next line. Okay, so now we're gonna do the same thing, except instead of name end, it's just gonna be ID end, and then ID. It's actually just gonna be one character. So it's just going to be, except of particle, it's going to be name end. So we're going to start at the end of the name. We're going to start, actually we're going to start here. We're going to start in the S because that's the next one. And then we're going to find that, and it should just be one. It should just be one character. But what I need is the end of it, just in case, right? And then we'll just say ID end. We'll just take the first one. We'll say it's, it's not really to do, but it's for me to find stuff like this. Undefined behavior with ID length greater than 1. Well, it's not undefined. ID length greater than 1 will just take the first as the ID. Perfect. And here will be the ID end. Okay. And where are we even using this? Okay, yeah, that's stupid. Okay, so now we have the name, the ID, and then we want a color. Are we assuming that there's a hashtag? Okay, yes, and then ID end. Okay, so now we're on ID end. This is where we are, at the end of the ID. And so now Now we need to parse the color. And I think what we're gonna do is we're gonna have a function that parses the color, right? And we're just gonna say parse color, and we're gonna pass in the start of the color, and then we're gonna pass the references to red, to green, and to blue. And then here, well, actually here, but we will just, it'll be a void, and it will be parse color. Let's just be string, and then it'll just say using, right? We will just copy this blue, green. Okay. And then here, what we can do here, I think we'll just do regular while loop. A regular while loop. What is this? Little Indian, big Indian. I was looking if there was like a hexadecimal, like an atoy. A toy. Okay, well, A2. Yeah. But for hex, it doesn't matter. It won't be too difficult to parse that. Okay, so first things, if. Okay, hold on. Let's get an I value. Int I equals 0. If stir I equals, if it starts with this, then we can just ignore it. Okay. And we'll just let that here. Ignore initial. Okay. And then we need to start parsing character by character. So actually, instead of this, if this is this, then we'll just move string by 1. Okay. And then we will say for, and we know that there's 6 characters. There's always 6 in a color, because we're not dealing with alpha values, because that's stupid. We might at some point, but for now, yeah, we'll just deal with the characters one by one. First things first, if the character is ever a next byte or I probably shouldn't be like error checking this much, but you know what? No, we're going to assume that the format is correct for now, and then we'll deal with it later. So now what we need to do is the first one is red. Okay, so how do we do this? I mean, why don't we just do something like, because 1 is 4 bits, so why don't we like grab like, okay, well, I think we could just straight up do this. We'll just say red is, should be red plus equals, and we will add, okay, first of all, we should set the stuff to 0. So red equals 0, and by red I mean this, and green, and blue. Okay, set those to 0. Start with those 0, and I'm actually going to put that here, because this is where we're doing the logic. Okay. And so we add 0 to it. Shift it over by 4. And when we do this, not shift it at all. And the difference is that here, instead of red, it's going to be green. And here, instead of red, it's going to be blue. Shit. not what I wanted to do. Here, instead of red, it's going to be blue. Okay. And then another thing is it's going to be 2, 3, 4, 5. Okay. And then I need to convert it to, yeah, whatever. Here, we'll just, int, whatever. Hex char to unit. That's fine. We'll try C. And we'll say here if C is greater than or equal to if okay, so here's what we'll do. First we'll just make it all uppercase. Screw it. So if C is greater than or equal to A, and C is less than or equal to Z, then what we're gonna do is we're gonna add the difference between A and A. Is that right, or do I have that backwards? That's backwards. Okay. That is backwards. This needs to be this, and this needs to be this, because we want to subtract the lower. So like if it is lowercase a, we need to subtract lowercase a, and then we need to add uppercase a. So that should do it. That should be the conversion. So now it's all uppercase, and then so now if. Okay, hold on. We actually also need to uint 8 value equals 0. Okay. So now we'll if. Okay, if C is greater than or equal to A and less than or equal to F, and what I want to do is I want to value is equal to 10 plus. Actually, I don't even need this. We will just return 10 plus, and then here we'll do C minus A. And that should do it, and then otherwise we'll just return C minus 0. Hopefully that'll work. I'm going to assume that it will, and then when it breaks, oopsie. And now here, what I can do is say hex char to uint. But instead of doing that, I'm going to see if I can do something like, oh my god, let's see if I can do something like, oh, bruh, yeah, what? Okay, so we're going to replace this with what? With hex char to uint, and then we say str, right? Yes, and then we'll just need to close the parentheses. There might have been a better way to do that, but that's just the fastest that I could think of. And hopefully that'll work. I think that will. I'm assuming this is bits. If I do that, yeah, that won't tell me what it is. Well, I'm going to assume that that's right. Okay. I'm going to assume that that's correct. Okay, and then we parse the color, so now we have the color, and then we need to start rules. So we need to start parsing rules. Okay, so for the rules, and actually this isn't even going to be, right, it's particle type, so type, okay, and then this just, we don't even need to do this, this should just be p.name, p.d, yeah, that should be fine, and p.red, dot should be the address of that, I believe. P dot blue. Yes. Okay. I think that'll work. It's the address of P blue. Yes. Okay. Next are the rules. So first we need to allocate space for the rules. So we'll say P dot rule count. We'll just say that we're going to assume that it's 1, but it can expand if necessary. And then so rules, we have to allocate this now, is now equal to a rule calloc. And then calloc was first the amount, which would be P rule count. And then otherwise, the size of rule. Am I correct in this? And bam, yes. Okay, so it's first it's the number and then it's how many. Okay, perfect. So now we'll say while. I don't know what there's another string, I guess. Yeah. Okay. So what we'll say is here. We'll say particle string is equal. I don't want to overwrite the actual particle string. Do I? I don't care. Okay. I don't. However, it does mean that I need to do this, and then here we say color and don't care about this. Let's put this here, and then color n plus equal 1, and then here we will say while the color. Right, I need to figure out how we're going to parse this. I think I'm going to assume that it's correct. I'm going to assume that the format is correct. And if it's not, then it'll just break and that'll be okay. Eventually, I would like to have some error checking so that the user can get some sort of feedback. But for now, I think I'm just going to assume that it's correct. And then color n plus equals 1 because of the extra line feed. And we just need to start reading. So while, I don't know, we'll just say while 1 for now. And so we need to read 3, and then no, we need to read 3 and then a line break, and then 3 and then a line break, and then 3 and then a line break. Okay. And we need to put that into the rules. So what we need to say is, oh, okay, while some condition, and we will say, and you know what? I think that means that we don't necessarily want the hyphens. I don't think those matter. I'd love some like get next line or something. I think I'm just gonna do it. Get next line string, and we're just gonna say steer char. Maybe working with a file is better. I'm gonna work with a file. File's gonna be easier. Particle file path. Yeah, path is gonna be easier to work with. Okay, so now file equals open. That's gonna be the particle file path, and we just want to read. And then we'll write, it'll be easier. And we'll just say char get next line and file. And we'll just allocate, I don't know, line is equal to char malloc. We'll just assume lines are, I don't know, 100 characters long. And no, we'll assume they're shorter. We'll assume they're only 16. And we can double it if it needs to be, that doesn't matter. And here we need to do size of char. Okay. So now we have the file. So that's our line. And we have fread. Read chunks of generic as possible, cancel each point and then mark with row. Okay, so we read. Okay, let me figure this one out. Command fread. Okay, so we read the size, the number. Okay, so we read. Oh wait, whoa. No. So we read the PTR. Reads n items of data, each size bytes long. So reads n items of data, 16. Each size bytes long, which is this one. Nope, I was incorrect. This many amount of data. Yeah, I'm reading it up here. So it's the pointer, and then it's the size, and then it's n. So I want to read 16 chars. So size of char. And then here we will pass in the file. Okay. And does it stop? Oh, it just does not matter. Equals the amount of bytes. Okay, so I need to read one at a time. Starting with the location given by PTR. Okay, so I need to read them one at a time. So we'll just say char C, and then we'll just feed it into the address of C, and we will just read the one. And then I think it's going to be while return the number of items read or written. This number equals the number of bytes transferred. Only one size is 1, which it is. Oh, it's size of char. If an error occurs at the end of the file is reached, the return value is a short item count or 0. Okay. So while, if an error occurs at the end of the file is reached. Okay, so while, and then we'll just do this. So while this is not equal to 0, then we will line I equals 0, and we will say line I equals C, line I is equals 1. If line I is greater than or equal to line size equals 16, we have to change this to line size. Just copy that. If is greater than line size, then what we're going to do is we're going to say line equals realloc. And yeah, well, it's worth a shot, I guess. Okay, what are we reallocating? We're reallocating the line, and with the line size, which we need to double. Okay. So that's a resize. This should read the file one at a time, and then the only thing that we will change is if C equals a new line, then we will just break out of the loop, and then here we will return the line. We'll resize the string. Okay. Yeah, so we'll break, and then we'll say, okay, well, what's the line I is the next byte that was going to be written. So if the line I was 15, it means we're going to write to the 16th number, which means there's exactly 15 characters in the thing. So now, we'll just say final. If I just reallocate, will that work? If I say line equals realloc, line, and the size is going to be, oh, you know what, hold on. This will work, but I don't. Size of chunk. I'm going to reallocate it to be line I plus 1 times size of char, and then line at line I should be the null byte. And again, we're just going to assume this works for now, and then when it breaks, I will come back and fix it. Okay, so now we have the next line, and this will also actually straight up skip the next line byte because it reads it. Perfect. Okay, so now, straight up p.name is just get next line. That is so incredible. ID, okay, ID is not quite get next line, but we can say ID equals get next line, pass in the file, we'll say p.id, it's just the ID, it's just the ID for the first value, and then free the ID. Okay, and the color, char color equals get next line at the file. We say color, we parse the color, and then we free the color. Wow, how much easier is this? Okay, perfect. Now, okay, now we don't even need to do this at all. Because what we need to do is we need to read 3 lines. So char first line, second, third. And we'll read into the first line. So first line equals get next line. Second, third. Do we even need that? I don't know, probably not. Let's see. No. And as a matter of fact, I don't even need it to be here. We'll say char line. Equals get next line. Pass in the file, and so this will be the first 3. And we'll just set an example with the sand specifically, just so I can see what's happening. Okay, so now with the top, and then what we need to say is, okay, and then we need to be like, okay, so the top, so p dot rules. Size, yeah, especially for like reallocating stuff. Okay, so rules at the rule count, and we'll say the input at 0 is equal to 0. Okay, another thing I want to do, and I'll put this in the proper include, I guess. Here, why not? Type def enum and we'll say what the top left will be northwest, and then north, and then northeast, and then west, and then center. And then east, and then southwest, and then south, and then southeast. Yes, and we will say that this is a dir. And hopefully this does work. What I can check though is C. I believe the first one, it just automatically sets it to 0. It does not need a comma, unchangeable values. Yes, okay, as you know, the first item of an enum has the value 0. Yeah, perfect, that's what I want. However, I would like to now, I'll just set it to, it doesn't matter, however, I'd rather be safe then sorry. And if we always use these values, then it actually won't even matter what they are, except for in the case of the array, the input and output arrays. So let's just go to particle here. There we go. Okay, and so this is actually going to be the northwest particle. Perfect. Okay, now we're cooking. Okay, so the rule count, and then this is just going to be north, and this is going to be northeast, and so it's just going to be the 1 and the 2, and we can free top. And we can just copy this, and here we can, instead of top, we can just call it middle, and here instead of top, we can call it bottom. And then I need to change, this should just be west, center, east, and this should be south, south. Perfect. Here I would like to specify that this is the S and this is the dot. Okay, so now we have the input. So what I'm going to do is I'm going to say that this does not need anything. And you can add that. And I believe get next line get next line file, and then if you choose to add a line break, a line scheme, I'm going to only allow one. I could while this, but it just doesn't matter. Yeah, so top O from, output, I guess. And then if top O if it's that, then we'll just do it again. I could literally say while, but whatever. Well, first let's free it, I think. Allow for single line break in between input and output. Okay, and then we just do exactly this. Except here, instead of top, it's top O. Here, instead of middle, it's middle O. Here, instead of bottom, it's bottom O, and then all here, instead of input, it's output. Okay. Okay. And that should be for one rule. This should define one rule. Okay, so this defines one rule, and now we need to check if there is a next rule. And the way that I'm going to do that, which is a little silly. Well, we can say the rule counts. We can say it's one greater, and then we can do the logic of if p rule count is greater than or equal to the rule size, then we need to p dot rules equals realloc p dot rules, and the size is going to be the rule size times the size of a rule, and we just need to do the rule size, and we'll just multiply it by Or should we add the 1 by 1? I don't know if reallocation is going to be that expensive. I don't think it matters. We'll just multiply by 2. Who cares? Does not matter. Eventually I might decide that I want to... Who cares? Okay, so now we've increased the rule count. Well, we don't need to increase it. We don't need to resize if we find out. So we'll just get a buffer. I'm gonna say there has to be at least one line break between rules, and you have to end the file on a rule. Like there can't be just an empty line at the bottom. Let's get next line. File. Okay, and then hold up. I actually need to return an error if you get to the end of file or something, right? So get next line. Yes. So if yeah. So what was this here? Okay. FEOF. I'm assuming that's end of file. Check and reset stream status. So FEOF. FEOF test the end of file indicator for the stream, returning non-zero. Non-zero if it is set. Okay. So here we go. If FEOF file if line I equals 0 and FEOF. I think that's it. Because if line I equals 0, that means oh, that means that this errored out immediately. Yeah, the fread errored out immediately. Or it was just a line break. If it was just a line break, oh, that's not great. Okay. Okay, well then it wouldn't FEOF. Okay, that's fine. Here we'll return null, and we'll have to free the line. Okay. Perfect. Okay. So if the buffer null EOF, then we're done. And we're done. Then we are done, and then we can return the P. Did that make sense? I sure hope so. Okay, let's just make a dummy print P type. Particle type. No reason not to spell this one out. Particle type. So to print it out, we'll just use printf. Here we'll say name, string, and it's going to be p.name. ID is a character in this case, and it's p.id. Print f, and then we'll say color, and this will be should be 3 of those. Yeah, hopefully. P.red, P.green, P.blue. Okay. And then the printf, we'll say rules with a new line, and don't forget the new line here. And then for I is less than p dot rule count. We'll just printf. We have to print them out line by line. So C, and this would be the p dot inputs input. No, we could definitely do something a little goofy. We could say like, what's it gonna be? Because I think it'd be really cool to have the rules look something like for example, in the case of this, it would be like, I don't know how many spaces. It's because it would be, the next line would be like s star s, and then I want an arrow, and then I want here s dot So it looks like that's 4 spaces. 1, 2, 3, 4, yes. So 1, 2, 3, 4, and then another C, C, C. Yeah. Okay, perfect. And then here is the line break. And then this should be P dot input, P dot rules, I dot input 0. Oh boy, this is gonna be something, isn't it? Okay. Yeah, this is gonna be something. Okay, bam, 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 bam. Okay. And then importantly, this is 2. This is output. This is 1. This is output. That's 0, but this is output. And then this is just 2, and this is just a 1. No, a 1. Okay, and then we'll have 3 of those. And I forgot 2, and that's, okay. Okay, and then here in the middle, I wanted to add an arrow. Okay, and then this will be 3, 4, 5, 3, 4, 5, 8, 7, 6, 8, oh, 7, 6. Okay. And hopefully that'll work. And don't forget just a dummy printf. That. You know what? I'll put this here at the very beginning, and then we don't put it here. Okay, so print particle type. I want that. Hold on, let me just. I think if I print particle type and then I get the parse particle type, let's put those in the include. Let's put those down here. Who cares? Okay, and then in the main, everything's broken. I know everything is just absolutely broken. But I want to get to the main function. Wow. Yeah, clearly. Okay, I'm just going to assume that this stuff is working. And if it doesn't, then I'll run the print. Oh, no, what I wanted to do, that's right. I don't actually want that there, because I want to, if I go here, at the very end of it, before returning, I'll print it. Print particle type, and we'll say P. And okay, and now is when I need to fix all this crap, So let's just go through the main function, and we're going to initialize the game state, and we're going to see. We're just going to go one by one. We're going to figure this one out. Okay, so we initialize the game state, and we set all the particles to empty. Okay, that means we need a default empty particle. We need a default particle. We need just an empty particle. Well, this is going to be really ugly if I do it like this, isn't it? Well, you know what? I'm just going to define it. What's the problem with that? So if we copy from particles, if we copy sand to empty, if we copy that, then all we need to do is parse that. So in the init, what we do is we create the particle type empty. And we set that equal to parse particle type, and then the particle file path is going to be right, we're in SRC. So how do we get C get we're going to be inside the build directory. Get file, get executable file location in C. Try to find the location of the executable. Can use a read link on this will read the return. Oh my god, this feels. To get the location of the current executed program. I'm gonna hard code this. I'm not gonna deal with it right now. Sandy articles empty. Absolutely disgusting. But yeah. Okay, so we're gonna parse this, and then the type is just gonna be empty. Perfect. Okay, so that's now working. I say working, like. Okay. Yes, okay, so here's another one. Sand. I need to figure out sand. So, okay, not in the loop, but out here. Why don't we particle type sand. And then we say parse particle type, and we'll just do the same thing. So me project sandy particle sand. Right, and then here, instead of saying sand like that, we say sand. And we're reallocating, everything seems to be working. This is sand. Oh, do we not have it here? Why don't I have it here? Add particle blob. Okay, yes, okay, this is the blob thing. And it needs a particle type. Oh, it just needs the actual type, not a pointer to the type. Okay, so particle type then. Particle type, aka struct as particle type. Yes, I'm telling you what the particle type is. I'm telling you it's sand. Oh right, I would have needed to do that. Okay. It's a little goofy. I might change that. For now, whatever. Okay, wait, hold on. Am I tripping? Oh, here needs to be empty, which we don't have. Okay. Should we make this global? I want to make these global. I know it's not the best, but eh. Eventually we'll have a. Oh, why is parse particle type not working? In the world, particle type key equals parse particle type. Oh, why is this giving me an error? Okay, what if I just do this? What if I bring those back to where they were? Did that go back? Yes. Okay. Maybe we can only declare things. So we'll just say sand, and then where is the empty? Here. And we will just declare them up here. Maybe that'll work? If I do like particle type and empty sand. That seems to have worked. And then what we need to do is down here, we're doing the blob. Here. Empty. Perfect. Okay, so that seems to have worked. The FPS seems to have worked. That seems to have worked. Now we need to update all of this crap. All of this. All of this. Okay. So we get the type. And get the ID. So we switch on the ID. And if it's a period, I just realized I never edited the empty. Hold on. Let me just do this before. Empty. It's gonna be a period. It's just gonna be black. I'm just gonna say it's black. And then no rules. No rules. No rules. And hopefully that's fine. Hopefully my parser can handle no rules. Yeah. Okay. So case period and then case s. So when we update that, it'll do nothing. Actually, we don't even need to switch on this stuff anymore because now I was defining the rules. I no longer need to define the rules. Now I need to just hey, I'm telling you what particle it is. I just need to grab the rules from it. Okay, so for yep, I is less than state. Oh, that's also wrong. Yeah, because I don't fuck with the board. Oh yeah, I do. State.board. I tried an optimization where instead of doing a double array, I just did a single array that was row major, and it had a small impact on performance. I was able to double the amount of particles on my laptop. Okay, type. I'm gonna say rule count. So I might put that back in at some point, but for now we'll just play with this because it wasn't that big of a deal, and right now I'm not looking at performance. I'm just looking at functionality. Okay, so for to types for the rules, I will say the rule. R, and we'll just set this equal to state board x y type rules I. So now we have our rule, and then for each of the rules we need to evaluate it. Okay. So okay, and then for each of the inputs, so for input for input equals 0. I don't know. This is not the best way to do it, but input is less than 9, less than 8, less than 8, less than 9, less than 9 because there are 9. Input plus. Maybe I don't want rules per particle and I just want global rules. I'll touch that later. Who cares? Okay, so input. For each input, what we need to do is we need to iterate. We need to figure out how to convert that into an offset. Right, because depending on the input is what I want to check. This is the direction I want to check. I'm just gonna add a helper function here. So state, no, it's just gonna be, what is it gonna be? It's gonna be an inbounds, but it's gonna be like with an offset. I'm gonna be able to just pass, hey, northwest or whatever. I'm gonna make it super ugly at first, and that's just gonna be okay. Oh god, it's gonna be terrible. Actually, no, hold on. If r dot input, if this is equal to a star, then just continue. That doesn't matter. Otherwise, we need to figure out which direction it is. Which direction it is. Yes. Okay. Otherwise, we need to figure out if it's inbounds. Yeah. How do I do that? how do we do that? I'm gonna make this really, really ugly. Yeah, I'm gonna do that. So if we just calculate an f offset and a y offset, and we say, well, we know that the x offset is left, if like left, so this way would be, this way would be -1, this way would be +1, right? So if it's on the left, which would be indices if the input is equal to northwest, or input is equal to just west, or input is equal to southwest, then the x offset is equal to -1. And then we change here all the w's for e's. Cooked. And then we do the same thing. So if the input is northwest, or the input is north, or the input is northeast, and then remember x is y, it goes like, so this is positive y, this is -1. So if it's north, so if it's the upper one, it means the y offset is -1. And if it's the other way, then it's +1. And I just saw that. Thank God I did. That would have been a terrible bug to not notice. Okay. And now what we need to do is check if in bounds, first of all, if it's in bounds, so x plus x off, and y plus y offset, so it's in bounds, and the state board x plus x offset, y plus y offset dot type. So if the type dot ID, if it's equal to the rule input, so if the ID is what it says that it is in the rule, then we continue. So what we will do is we'll say if it's not equal, then we're done. Invalid rule. So we just break, because that rule does not work. So we break out of this loop. Okay. However, if all of the rules pass, that means we never break. Okay, we'll just have a valid here. Rule valid. True. Wow, that's wild. We'll just say that it's valid by default, and then we'll say rule valid, invalid. Okay. And then if rule valid, which means that all of the checks passed, so we have exactly the case that is said, then this would be if not in bounds. So if it's not in bounds, so wait, no. So if it's not in bounds, or it's not the input. So either. If it is not in bounds, then it will just break. But if it is in bounds, then it needs to check the other thing. That's what it was. Okay. So now if the rule is valid, then what we do is we need to replace all of So for int output equals northwest, which I believe is the first one, but we'll just set to 0. Output is less than 9. Output plus. And we do like very similar logic, honestly. If it's a star, then we don't care. We'll do the opposite. If the rule valid is 0, that means it was an invalid rule. We will continue to the next rule. Otherwise, yeah, if the output, stupid hair in my mouth. So if it's a star, we don't care. And we calculate the same offsets. This is absolutely terrible, but damn. Let me do that one more time. Input, output, just make sure, yeah, toggle that. Okay. Yes, so now we have the offsets, and then if inbounds x plus x offset y plus y offset. So if it's inbounds, then wow, that is not the bracing I meant to use. Then we need to replace the state.board x plus x offset, y plus y offset. We need to change the type. We need to change the type. The question is, how do we get the types? Because they're not here. So it's like we need to have, in the state, we need to have a list of particle types. Yes. We have a list of particle types. Yes, we do. Okay. So that means we have to go all the way up. We have to go to the game state. Okay, yeah, that'll be fine. Oh, that's not the one I wanted to find. Should be here. Yep. Particle types. Yeah, I definitely don't want to do that. So before declare it. Yeah, particle types. So it'll just be types. Particle types. And then we'll just add another function. We'll just say particle type get particle type, and we pass in a game state. And an ID. And that'll just do whatever. Okay. So then here, I believe it'll be here. No, it'll be here. Yes. Okay. And all this will do, we'll just say for int I equals 0. I should probably get how many there are. Oh my god. Yes, particle int particle type count. Okay. So this I is less than state dot particle type count I plus if state dot particle types I dot ID. Oh. I think I can include it here. Particle.h. I think I can do that. I think that's fine. Yes, so if ID equals ID, then we just return it. And we just return the state.particle types I. Correct. We need to return the address. The address? Do I want an address of that? I'm like hoping that they don't change it. I mean, whatever. And they'll just return null otherwise. Because it's not defined? What in the world? What is this not defined? Whatever. Yeah, so save that. This is totally just gonna break absolutely everything, but whatever. Okay, so when we initialize it, okay, so when we initialize the game state, now is when we get to parse all the types, except at the very beginning, and then the empty is just the empty. That's fine. Yeah, we'll parse it here, and we'll say get files in directory. How can I determine? I'll execute the ls command. This is a duplicate of this. There's not an official way yet, but it's not C++. So why don't you figure this out? Why are we in C++ again? Inside my C or C++? No. I guess we're looking at geeks for geeks. That's fine. Oh my god, we're doing this stupid dir end stuff? Points a pointer of dir type. And we'll read dir. We get a list of files. Dname. Okay. And we need dir end, so void parse all particle types. Game state. That's it. Okay, and here we needed to include dir end. Okay. Yes. Wow. Formatting. Pointer for directory entry, returns a pointer, and then here it's just gonna, I'm hard coding the crap out of this, but okay. If couldn't open directory, yeah, we're not gonna return anything. It's just gonna be returned. Who cares? Why is there this weird space here? Okay. Sure, whatever. Read dir. Let's figure out what this does. Man, read dir. Read dir function returns a pointer. And it will be the name, the inode number, length, type of file, not supported by all files type systems. Okay, dtype. Okay, and it just needs to be not a directory. Nope, it needs to be a regular file. Cool. Okay. So while it's not null, if de.dtype, if it's not, what was this, reg? If it's not that, then continue. And if it is, then we need file path is going to be sprintf, I think. Right, formatted output to S, yes. Okay. And we're writing it to file path. Does sprintf allocate or no? sprintf, write at most, size bytes, I don't care. Sprintf, it doesn't explain it. Printf, write output, the standard, and that would cause copying to take place, don't care. Sprintf, caveats. Depending on the version, oh my god, I'm just going to assume that I need to allocate memory for it. I think I do. I mean, how big can this even be, right? It's just gonna be, let's put this here. And we'll say that this is calc, and we'll say how much. Well, this is just going to be size of char. That one's easy. What's not easy here is we'll just say strlen, and here we'll put the slash home. Yeah, so we'll do that, and oh, I don't want strn. I just want strlen. That's fine. Yeah, so the strlen of that, and then we'll add on. I don't know what's the biggest file name that it could get. I don't know. We'll say 32. Fix the fuck out of this. Fix the fuck out of this. Okay, and then we will sprintf the file path to the file path. S, and then here will be the de dot name. And so now we have the file path, and so now we need to parse particle type with the file path. So we have file path, and we get back a particle type. Okay. Oh my god. Okay, so now once this has happened, we can go state particle type count is equal to 0. Here we'll say int particle type size. We'll say this, or we'll call it capacity, and we'll just say for now that it's gonna be 2, which means it won't need to reallocate for my case, but you never know. And state dot particle types equals calc, and then we want particle type capacity. Sorry, that one, just so I know that the resizing works. Particle type capacity, and then particle type capacity, and then the size of particle type. Okay. So now that's happening. Then we need to say that particle state dot state particle types state particle type count equals that state dot particle type count equals, just add 1 to it, and then if particle type count is greater than or equal to particle type capacity, then state dot particle types is reallocate into state dot particle types, and again particle type capacity, which we increment by 2. That should work. Oh, first particle type. What am I doing wrong? It returns a pointer. Okay, so we'll just dereference that pointer. That's fine. Who cares? Yeah. Oh, that's weird. Well, whatever. It's fine. Okay. Okay, so parse all particle types. Now we're parsing all of them. So I don't need to do this. I'll actually leave that there. And I'll say parse all particle types, and we'll pass in the state, and hopefully that will just work. And then the empty is actually going to be get particle type, and we're going to pass in the state, and then we're going to say the ID is the period, because that's the empty one. Okay, do I have a get particle type? I do, right? Yes, that's right. Okay. Okay, so now this should be better. And then the only thing that I want to do is this should be get particle type state. Should just be that. Okay. And then I want to see if my stuff is here. That's fine. That's fine. That's fine. Okay, perfect. There's no way that this is currently working, by the way. Yeah, because here in particle we need to fix a ton of stuff. Okay. Right, because now, this is because of this. Because now we can come here and say we want to get the particle type of the state with the ID of output, except output, oh, not output, r dot output, which should be a character. And then get the particle type, and that returns what I need. This returns a pointer, and the type is a pointer. Okay. Hopefully this works. Great, we don't actually need any of this anymore, so that's pretty cool. And then the only thing that we need to do here is we have a particle type, and we'll just make it a pointer. Make this a pointer, make this a pointer, because it's not an enum anymore. Before it was an enum, now it's no longer an enum. Add particle, yeah, that will be fixed as soon as I update the include, which will be here. Yes. Okay. Wow. Okay. Incompatible particle type. Okay. Yes. So let me just look up sand. Oh, why is this not? Do I need to do that? Yeah, I do. Okay, yes. So delete this, delete that. Directive writing up to 255 bytes into a region of size 32. Fine. What I'll just do here is I'll just may write a terminating null past the end of the destination. Sorry. I think if I make this a 6, it'll... There we go. Question is, will it work? Segfault. Okay. Oh, now we need to figure out why it's segfaulted. And I don't have a goddamn clue. I'm going to assume that it was in the parsing. And so what we're going to do... Yeah, because we should have gotten some output. Because when we parse a particle, it should have done something. So it's not a regular file, okay. And then I want to actually like printf particle file found. And then here we'll say file path. So we found sand. We didn't find... Okay, so we broke almost definitely on the parsing. Okay. I mean that's good. That helps me render it down. So we found it. And then we parse the part. I'm assuming it doesn't get parsed. Yeah, it doesn't get parsed. Okay. So let me get to the parse. Yeah, because it doesn't even print it. Okay, so we need to figure out what's breaking. What is breaking? We have the particle type, and we malloc the size of the particle type. We open the file. The name is the next line. ID is the next thing, and then we free it. Okay. We printf parsed name. Yeah, hold on. Parsed name, parsed ID, parsed color. we will actually just straight up do this. Name and then parse color, and I won't do this one. Screw that one. Parse ID, parse, and then the color is parsed. So I'm assuming it's the rules. Oh, you know what it might be? Yep, it's this. I forgot to remove it. I don't know if that's actually the reason. You know what I mean? Okay, it's not. But that would have been funny if that was the reason. Oh, and the empty one. The empty one would also have... No, because there's no rules. Is it okay that there's no rules? I spelled empty wrong. M-D. Is it okay that there's no rules? I mean, I guess the parser will find out. Well, it doesn't matter because the first one we find is empty. Oh. Well, it doesn't matter if... Well, the first one we find is sand, and then it breaks. So that doesn't matter. It's the parsing that, like, something's wrong with the parsing. Parse. Wrong one. Okay. Okay, so calc the rule size set to do rule. Okay. Not for a single break. Okay. We parse 3 rules. We do parse 3 rules. Okay, that's good, actually. That's really good. That's really, really, really good, actually. Because that means we are parsing rules. Is it the print that's breaking? Is it the stupid print that's breaking? Is it the stupid print that's breaking? There's no way, right? Yeah, that's fine. Hold on. If we go to the particle, we parse 3 rules, and EOL. We'll just say EOL. We'll see what happens. Because if it's not getting to EOL, then we know that that's the problem, right? Okay, we're not getting an EOL. That's okay. I think I found the problem. We're not returning null on the get next line. Why are we not getting an end of file? Stop. 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 This is just so much better. Just do that. This should be better. Okay. I have a feeling that it's something in here that's not working. That's trying to write or read something that it shouldn't. here it's gonna read a 0. Okay, here we go. And then here we say if FEOF, then we just return the line. Well, that shouldn't matter. This should not even matter, because if we just hit the end of the line, then it shouldn't matter. Should straight up not matter. Should straight up not matter. We are getting to the end of file, but we're never like getting an error because of it, and I think that's a problem. If FEOF return null. The big problem is we're not getting null on the buffer, and we're getting null on the next buffer. Right? If I do here like printf got line line look, we got an empty line. What's with the empty line? Oh, hold on. What is this? Oh, that's super broken. Oh, boy. Oh, no, no, no. Okay, I think I see it. Yeah. So we have a line here. So we get this line, we parse the color, and then we just get an empty line. Because I forgot to remove the empty line. Oh, okay. Right. Okay. Buffer equals get next line. Empty line. And we'll free the buffer. Okay. Okay. And then we get, oh, that's fine. That should be the buffer, right? And then we get an empty line at the end. So we need to figure out why that happens. And I think what I need to do is that was correct. FEOF. If we need to do the thing that we did here as well. If line I equals 0 and also free line and return null. Because I think otherwise. Okay, here we go. Okay, so we look at that. Oh, look at the rules are showing up. Oh, that's sick. Okay, so that's working, and now I was correct. We get a seg fault if we parse the color and there's nothing there. But we can just change that. That's fine. That doesn't matter. Particle parse. Okay. Should be an empty line. Okay, so we try to free. I think we try to free. No. It should be an empty line. Well, yeah. Okay, and if here we go. If top equals null, no rules. And what we will do here is we'll just return key. Does that make sense? Is there any cleanup that I need to do that I do on the bottom? No. Well, print, I guess. But that's fine. Okay. We open the window. That's something. Okay. We open the window. That's perfect. Now we need to go down to all these printfs. The got line, we don't need that anymore. Those we do. Parse name. Parse the rule. EOL. I don't know. I don't know if I like the fact that that never actually gets tripped, but whatever. Okay. So we get the window open for a second, and then we segfault. Okay. We're almost there. Now we just need to figure out why we're segfaulting when we're doing that. And I have a feeling it has to do with the state. I have a feeling it has to do with the state. Where could we be segfaulting? Does Valgrind help find segfault? Okay, here we go. Who cares? I'm not sure how the line could be generating. Yeah, let's do it with Valgrind. Let's figure this one out. Valgrind might go. Valgrind build cannot continue. Fatal error. A function redirection which is mandatory cannot be set up details its redirection. It must be redirected function whose name matches the pattern as an object assembly magic. It's not found as processing symbols. Possible fixes install glibc's debug info. Ask the packagers for Linux to please in future ship a non-stripped or other dynamic sold on Debian. Okay. libc6 dbg. Okay. That's not there. That's delightful. libc6. Uh-oh. Maybe it's glibc debug info? I probably should have checked that first. glibc d... Oh, God. I'm just gonna glibc... Oh, boy. On Arch Linux. Maybe there's a Valgrind. Yeah, there it is. I looked at the commits. Same here, using debug info. I was facing the same mode. Okay, debug info D. Okay. After a reboot and mirror update, it worked. Okay. So debug info. It's called, what is it? Debug info. I looked at the commits and Valgrind was able to get the glib from debug info D. I've installed the debug info D package. Okay, so it is installing debug info D. Okay. Should automatically set that NV, maybe restart. If you're just new, export the above in your file. Okay, well, I could just export that. And then hopefully, damn. Okay, let's figure this out. Debugging, yeah, I don't care. Okay, can be downloaded via debug info. Enhanced debug information and not entity executable, getting the trace. Yeah, but this is for GDB. I don't care about GDB, I care about Valgrind. Make sure I'm not a robot, okay. Check availability, okay, GDB, there's several techniques, okay. Running it from GDB, no. I want to run Valgrind, here we go. Valgrind can also be used to detect these behaviors. Also see hashtag Valgrind. Assuming that you have an unstripped binary is a good idea. Valgrind is a tool that emulates. Okay. It's just Valgrind. Okay. Perhaps I need to update it? Like what? Nope, it's this. Valgrind first. Okay, here, let's try this one. Valgrind, when attempting this message appears. I've tried rebooting my system and my debug info URLs looks like. Yeah, actually, hold on, let me try this. I'm assuming that since I've exported it. Yeah. This is the output for pacman debug info d info algorithm, blah 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 blah. Okay, what is the full command you use? Algorithm ls, it's in the log. Does your LD have a debug info section or your latest version of glibc? When was your last pacman SYU? Yeah, so this literally did not help. On the latest version of glibc. I mean, I guess I could update it, but I'm not updating my entire system just for this one stupid thing. And yes, I am on the latest. Yeah, so that didn't absolutely help. Okay, which package install instead of, okay, there's no package. It looks like you need the debug options or else Arch strips the symbols. Do not strip these for D2B, but strip the rest. Oh, that's really stupid. That's absolutely terrible. Okay, let's try this. Let's run it. Set this variable in reboot. Okay, do I have to reboot it? Okay, I'm gonna reboot. I'll be back. I got it. So I had to reboot, and then that didn't work, so I just updated all my packages, and then it seems to be working. So let's figure out what happens. Invalid write. Okay, so I love this. I love this Valgrind. It's so incredible. Okay, invalid write of size 8. In parse all particle types. In parse all particle types. Does it tell me? Yeah, unfortunately it doesn't tell me the actual line that it's happening on, but we know it's in parse all particle types, which I think is really useful. Because now if we come here, well, we don't even parse all particle types. We know it's in here. You know, it's something here. The question is, where? Where? Do we ever print out parsed? Because if not, then it's right here. This is that, and this should be dereferencing it. Yeah, that should be an error. Particle file found, and then we try to parse it, and then do we get a? Oops. We don't. Oh, we do get a parsed. We do get a parsed. So we get both of them parsed, and then we get an invalid write somewhere. Parse all particle types. We do get a parsed. We do get both of these, and then we get a invalid write. Oh, it's here. It's definitely here. It has to be. Realloc. Particle. Oh, that's what it is. I knew it. Every time. Every time. Particle type. Yep. Every time, dude. It's always the same stuff. Always the same crap. Okay. No, but oh, yeah, if I actually, build it. Look at that. Didn't break. Uh-oh. Oh, okay. Realloc with size 0, invalid size 8. Please! Please! Okay. Well, I have to kill it now. There it is. What is that? 4,500? Die. Oh my god, why won't you die? Yeah, absolutely die. Okay, so now we try to run it normally, and we get a window, and if I... Look at that! And it works! And it's ideally data-driven. It's a bit yellower than before, is it? That's crazy. I didn't even actually do anything. But now, that means we can change the rules. Yeah, this is like way less performant than it was before. Anyway. But now that means that I can change the rules just like this. Like, for example, I can say, well, actually, sand doesn't go down anymore. Sand goes up. Sand goes up. And then here, it will be, the S will be here. Actually, I need to change this here as well. This would be that. And I can add these now, which is good. I wish I could add more, but you know what? This is fine. Replace that with an asterisk. And then here, replace this with a dot, replace this with an asterisk, replace this with an S, replace this with an asterisk. And that should be correct. And now I don't even need to... Oh. Oh, I know why it's happening. Because I update from the bottom up, which means that the particle at the very bottom, you can't see it, but the particle, like if I put in one particle, it'll get updated to the top. It won't just get updated one time, but it, yeah. But it is technically flowing up. It's just, you know, like not in the best way. But like for example here, I'll try and explain what I mean. Excalidraw. I was explaining how keys work. My algorithm goes like from bottom up and it just goes updating like this, and this and this and this. So if I have a particle here and it moves up, it's on when it cuts to here, it'll move up to here, and then when it gets to here, it'll move to here, all in the same frame. You know, which is not ideal. So maybe we want to do like one line per frame. That would be interesting. Maybe we want to update top down. Maybe I don't know. I haven't figured that one out yet. But yeah, look at that. Look at that. I can change the rules. I'm putting this back to how it was before. I think that's right. No, I think that's right. Still no. Yeah, there we go. Now that's correct, and that's correct. Okay. Nope. That's wild. I can make sand duplicate. I'm not going to, but I could. Anyway, 1 second. But yeah, that's so cool. And I mean, in theory, I could make other particles and have those work, but I don't have a way to like pick what particle I want to add. But yeah, look at that. I mean, I guess another thing. I mean, I would like to try. Like, sand could get duplicated, right? That's not what I want to look at. I want to look at the particles, and I want to go to the sand one, and I could be like, oh, well, look at that. If my apologies. Thanks. If sand can fall, it'll just infinitely fall. So if I put that there, that's so stupid. Oh, that's so awesome. Oh, that's so unbelievably stupid. Oh, hold on. Is it? I actually just had a thought. Other than, you know, that being goofy as hell, is it possible it's running all the rules? Does that look like more sand? It looks like it could be more sand than I put in. Like if I put in this much sand. I'm just trying to gauge if it's more than I put in or not. I think it might be. I think it might be following both rules if it can. Let's go to here, particle, update particle. Yes. Oh, okay, so here it is. Okay, yeah, so that's what I need to do. So rule valid. So now what I need to say, if the rule was valid, yes, okay. Rule isn't valid, continue. And if the rule was valid, then break. Because only one rule. Okay. You can't update and then update again. That would be stupid. Which is why it exploded into a pyramid, because it was just constantly running all the rules, like the first rule, and then the second rule, and then the third rule. That was constantly doing that. Okay, if rule out equals 1, break. Okay, I think that's fine. And we make it, run it, and this should still work like a normal sand simulator, and it should not break, other than, you know, being really laggy. That means that if I go and update this, where'd my screen go? What happened? What the? What in the world is happening? Particles, sand. Okay. Sure, dude. Whatever you say, my guy. If I go back to making this, then it should stream down first. I don't even have to, like, rebuild it. That's the best part. Oh, that's so stupid. It's slower. Okay. It is going down first, but because of the nature of the other thing. Yeah, alright. Well, cool. Next would probably be adding a way to change what you're drawing. Because right now I just have it left for sand and right click for empty, but maybe we want to use like the number keys or something. I don't know. But there we go. That's pretty cool. Maybe we want to use the actual text, so maybe like S open. Anyway, who cares? Good stuff. See ya.